Hey guys, what's going on there? In this video, I'm going to be talking about network meta-analysis for beginners. So if you look at my past video, I've made a lot of videos on meta-analysis, how to conduct systematic reviews, and also videos around several domains. Now, in this particular video, I'm going to be talking about what meta-analysis is. And now, one of the things I'm not going to be doing in this video is I'm not going to really practice with the research question because I actually want you to understand the foundation and have a very theoretical understanding of what network meta-analysis really is. Now, in my subsequent videos, I'm going to actually employ practical tools using R Studio on R, to execute practicals on how to perform a network meta-analysis. So actually enjoying you to like this video, share this video, and actually engage and tell me areas you would want me to make further future videos around. Now let's get started. Now, we are going to be talking about network meta-analysis once more for beginners. So we're going to actually be looking at some of the concepts and some of the practical steps. And one of the things we need to actually understand is that we might want to know what is a network meta-analysis. Usually, beyond the normal traditional meta-analysis that we usually do, where we pick one intervention A versus intervention B, and we try to actually draw comparisons between these two interventions to get an estimate that we could say that so and so favors this intervention over the other intervention. Okay, so I just get that simple. Now, when we talk about network meta-analysis, now what changed from meta-analysis? One of the things that changed is that we use the word network in it. So it's more like actually an advanced form of meta-analysis that allows for more comprehensive comparison. Now, when we say networks, now think about it as a node. You have a node here. So you've got node A, you've got node B, you've got node C, you've got node D and E. Now, between these nodes, now there are several connections between node A and B. There's a connection between node A and C. There's a connection between node A and E. There's a connection between node A and F, or depending on how many nodes there. So what network analysis tries to understand is that we want to actually compare multiple interventions, or want to compare multiple interventions, right? Either directly or indirectly. So here, when we talk about multiple treatments, one analysis, essentially, what this means is that it simultaneously compares, multiple treatments, even those that are not directly tested against each other. So it can't be that we're trying to compare paracetamol versus metronidazole. Basically, what I actually want you to understand here now is that when we are comparing two interventions, right? Maybe we're comparing one drug A versus drug B and drug C. Now, it could be that we're trying to compare drug A and B, or maybe drug A and C, but invariably we still see ourselves showing estimate of drug A versus B, which is what more like an indirect comparison. So whenever we're performing a meta-analysis, more like we'll have a one research question, then we now want to compare several interventions. So it leverages all evidences, right? So in network meta-analysis, it integrates both direct and indirect evidence, just like I explained, to form a complete picture. So just think about it as you will want to compare a certain group of drugs about a particular condition and want to actually know which of them that is most efficacious amongst all of them. Now, the traditional meta-analysis is usually done between two interventions, where we try to compare between class A versus class B. But in a network meta-analysis, we can compare multiple interventions at the same time, either directly or indirectly. So another thing we need to actually understand about network and meta-analysis is that we're trying to identify the optimal treatment. Okay, so the goal is to actually understand which of them which is most efficacious or effective, or probably the most safest treatment among several options. So it's actually a very massive area for you to get started with. Now, why do we need network meta-analysis? Okay, that's the question. Now, looking at the first explanation that I did make, now you would understand that some of the limitations of the traditional meta-analysis is that we are only comparing two treatments at a time. Now, but in terms of a network meta-analysis, we're actually trying to address some kind of complexities between several treatments at the same time. So it means that any research question that is being drawn from the position or the statistical standpoint of a network and meta-analysis is trying to understand the best approach across a wide array of interventions or a wide array of treatments. So it's actually very important for you to understand the foundations of network meta-analysis before we dive into the practicals, because the network meta-analysis makes it makes the process invaluable for developing what clinical guidelines. Because at the end of the day, what we might say is that we are trying to understand which drug is most effective for managing type 2 diabetes. And we have metformin, we have maybe another drug B, we have another one for another drug, we have another one that's class 4 drugs. Now, essentially, what this particular procedure is doing is that we want to now know which amongst all of these 4 drugs that is currently on the treatment pathway is most efficacious or is more safe, relatively safe, for policymakers to place probably at the first line of, treatment pathway or second line, depending on how the number of nodes that we are trying to compare. Now, I'm going to actually explain something very simple in this crash course, because the idea for this course is to make it very simple and easy for each and every one of you to understand what we are talking about. Now, just like I actually explained about having multiple nodes, when we talk about a network meta-analysis now, it is not really far-fetched from the traditional meta-analysis where we have 2 interventions. But here is the point that I actually want you to get right away. That when we are comparing or when we are performing a direct meta-analysis or a traditional meta-analysis, now here are some of the options we might have. We might actually have maybe treatment A versus treatment B, or we have treatment A versus placebo, or we have treatment A versus control, or we have treatment A versus another form of intervention. And now, what type of intervention is it? This is more like a direct comparison, because we are trying to make inference from drug A versus drug B with respect to some relative outcomes of interest. So this could be some kind of form of primary outcomes, like maybe all-time mortality. It could be maybe change in baseline blood pressure, or change in baseline glucose level, whatever intervention or outcome that you are targeting. But the good stuff of this explanation is that when you're conducting a normal traditional meta-analysis, it usually involves 2 interventions, right? You've got class A and class B, and then you do a direct intervention. Now, but let's look at what a network meta-analysis looks like here. Is that you can actually be doing a direct evidence, right? Where you're comparing node A versus node B, right? Where you're trying to actually understand how directly connected this particular class of drug is to this particular class of drug, right? Or it could be any form of intervention aside from therapeutics or whatever. Now, but the idea here is that when you talk about direct evidence, you're saying, okay, we're trying to make a comparison of treatment A versus B directly, maybe 2 randomized trials. But if we're actually looking at indirect evidence, now, since we're comparing node A with node B, so indirectly, we can actually be having pooled evidence of node A to node C. Now, that's why we say it's a comparison of treatment of A versus C, which is actually inferred through a common comparator of B, which can be A versus B, B versus C, which also implies A versus C. Okay, so these are actually some kind of indirect evidence that pulls on when you're actually performing a network meta-analysis. And I'm going to talk about some of the strengths of a network meta-analysis, because when we actually have the opportunity of comparing multiple interventions at the same time, essentially what it does is that it generates a more comprehensive treatment evidence effect estimate for us. So on the course of interpreting the results from a network meta-analysis, what it does is that you actually get much more solid evidence, which is gotten from indirect studies that maybe, or direct indirect probably interventions that weren't of interest to you, but you already have the result pulled from there. So you can actually now make inference from it into your result. Now, the next thing we're going to actually look at now is I'm just going to paint a visual picture of what a network looks like, because when I talk about network meta-analysis, a couple of persons might be lost with what I was talking about. But basically, this is what a network looks like, okay? Now, what's a network? Now, a network comprises of a node, right? A node. So when we talk about a node now, is that we've got several nodes. We've got node A here, we've got node B, we've got node C, and till node I, whatever nodes, right? So the treatments, some of them were actually the nodes. This is node A, this is node B, this is actually another node C. So when we talk about nodes, we're talking about several treatments. And each of these nodes, like I said here, represents a treatment which is going to be compared. Now we're going to look at what we call the lines now. And what do we mean by lines? And when you actually look at some of these nodes here, you see that there are actually some lines that are connecting each of them. You see, line node A is being connected to node B, and node B is connected to node C is connected to node E, and that of that. This is what purely a network is all about. Now think about this network as MTN, or think about it as any kind of traditional networking system or networking package that's in your country. And when you look at some of these nodes, or when you look at some of these networks, you see that the networking, when you've done, if you're somebody you've done computer networking, you see that the internet is connected with various nodes. So look at it that your phone is connected to the server out there online, then the server is connected to another phone, that phone is connected to another server, that is also connected to another Wi-Fi, is connected to several nodes. Now, that is what we talk about. Now, what connects them is what we call the line. And this is a very, very crucial part in the interpretation of our network meta-analysis. And that's why it's actually very imperative for you to understand what this picture is and actually create a mental understanding of what we're talking about. So the lines are the more like here that you can actually see at the edges, they connect the treatments, that have been directly compared in a study. So what this means is that when we look at study A and study B, we see that what connects them is this line. It's connecting two of the studies, which or these interventions could actually be serving as a node. So they have a line, no lines connecting them. Now we're actually going to actually see what we call the visual cues. And now, what do we mean by visual cues now? So I actually say that sometimes some larger nodes often signify more studies, for that treatment, while thicker lines, indicate stronger evidence for that comparison. Now, I'm actually going to actually explain this as, think about it as whenever we're trying to interpret the diamond when we are doing our traditional two-way meta-analysis, where we're comparing two interventions or two treatment effects. Now, when the diamond is big, what do we say? We can actually say there's maybe probably there is a more wider confidence interval, or there is more study weighting. Each one study has more weight compared to the other study. And essentially, what this means is that when we are inferring this into network meta-analysis that has several interventions connecting to them to several nodes, it's trying to explain in simple detail that larger nodes now will often signify more studies for that particular treatment. Do you understand? Now, why some of the thicker lines, why there is now thicker lines, which we can actually interpret as usually confidence intervals whenever we're doing that direct study comparisons for two studies. So those thicker lines are now going to indicate stronger evidence for that comparison. So this is just like a mental picture that I want you to have based on this particular network image that I have displayed right here. Now, for the network plots, now visually they represent the available evidence, the available evidence structure, making it easier to understand which treatment have been compared and how robust, this evidence is. Now, we're actually going to look at something that we call some of the assumptions in network meta-analysis. And what are some of the assumptions that we have in network meta-analysis? Some of them is transitivity. Most times there is this core assumption that studies are clinically and methodologically similar, enough to allow for indirect comparisons. And this is something that means that, the characteristics of the patients and interventions across different trials should be comparable. So it doesn't mean that you should not make inference, when there are some kind of heterogeneity in the trials that you're trying to compare in that pool of network intervention or network meta-analysis. And another one there is what we call consistency, right? So many a times, there's this assumption that direct and indirect evidence for a particular comparison provides similar effect estimate. And these inconsistencies can indicate underlying issues in the network. And one of the things I want you to understand is that most times, just like we have for the normal traditional meta-analysis where we do account for homogeneity across some of the trials, it is essential for you to understand that trials included in the network, some of them should have similar patient population. And this is an assumption that is usually being made: outcome definitions, intervention duration, and there are several parameters that we usually extract during our data extraction, more like I would say study methodologies to ensure valid comparisons. So it is important for you to know that if you violate some of these assumptions, there are tendencies for you to lead to biased results. Making careful assessments crucial for validity of the network meta-analysis. And I think one of the things you need to understand from this very short crash course is that when I'm actually going to pull out a practical on this. Essentially, this is actually going to make a lot of sense because it will give you some of the highlights and also how to understand this much more properly and clearer. Now, what are actually some of the main outputs for a meta-analysis? Now, I would say for a normal meta-analysis, we look at confidence interval, we look at some of the heterogeneity score, which usually measure tau squared, that's in between study consistency. That's we're trying to measure the internal consistency. We've got several parameters like the I squared when we're trying to understand the heterogeneity among studies, and our pooled effect and all of that. We've got forest plot and all of that, funnel plot as usual. Now, but in the case of a network meta-analysis right now, we have what we call the network plot. So that is what we're also going to generate on the course of our practicals. We're going to generate a network plot. And essentially what the network plot is that it's actually a visual representative of the treatment comparison and available evidence. Now, another parameter that we are going to be interested in is what we call the treatment ranking. And just think about it more like as a hierarchical, ordering of treatments from best to worst based on a specific outcome, often visualized using ranking, probability. So that's what we use the ranking probabilities to show whenever we display the results of a network meta-analysis. Now, another thing that's also going to be important to us on the course of this course is a relative treatment effect. Now, just think about it as the overall effect when you're doing a normal traditional meta-analysis. But in this case, we're going to actually be looking at some of the estimates of how each of these treatments, compares to every other treatment in the network. Because we have several nodes that are being connected with several lines. Remember how I actually explained it in my previous slide. Now, but what we want to know now is I want to actually understand what's actually the estimate of how some of these treatments compares to every other treatment that's on that node in the network, and how is many a times you actually present this as odds ratios, mean difference. So some of those statistical estimates that I have actually explained to you in my previous videos for a meta-analysis also applies in your network meta-analysis for the interpretation of a result. Now, another thing that we need to actually understand is what we call the league tables. Okay, so the league tables and what we call the SUCRA. So more like what the league tables does in the network meta-analysis is that it provides a comprehensive pairwise comparison, right? So why the surface under the cumulative ranking score, which you call the SUCRA ranking curve rather, what it does is that this ones quantify the probability scores of a treatment that is being among some of the best. So we're actually going to explain all of this, show you how the league tables works in network meta-analysis and how you can actually get started, at least with the basic meta-analysis of a pooled prevalence across several studies. Now, we're actually going to be looking at some of the steps for you to perform a meta-analysis, a network meta-analysis. So now, this is actually not different from what we do in a systematic review or a meta-analysis, where you start for a network meta-analysis, you define your research question. Now, it's actually very, very important for you to understand that whenever you're performing a network meta-analysis, it's usually best to whenever you're using an effective intervention estimate. And a research model or research question that is usually suitable for this is what we call the PICO model. And what's the PICO model? What the PICO model does is that you have your population, you have your intervention, you have your comparator, you have your outcome. So we try to clearly specify what is the population, intervention, comparator, and outcome. So we actually pick out all these parameters because they're actually very important when we are queuing in our data. And then essentially, the next thing you're going to do now is, well, you're going to do a systematic literature search. So that means you're going to actually search on several databases like Cochrane Central, which is actually one of the best informed database for you to identify trials. And you can actually search at trial.gov. You can also search on, Embase via Ovid. You can search on, Medline via Ovid. You can also search on Scopus. You can search on PubMed. And there are a lot of repositories out there that is going to be very important for your search. Now, a very crucial part of our network meta-analysis step is what we call the data extraction. So what do we mean by data extraction? It means that you're definitely going to pull out studies from all of these findings that you've pulled out. So it means that if you've got like 9 trials, you have to extract study information, parameters from each of them, because these quantitative estimates that you're going to extract from them is going to be very relevant for you to queue it in for us to perform a network meta-analysis. And that means you have to extract all the key information from included studies, including treatment arms, the outcomes, probably primary outcomes, secondary outcomes that are going to be very imperative for your explanation. And then also You can also build the treatment network, which is something I'm going to show you in the next video in my practicals, and probably how to map out the direct comparisons to visualize the network structure. And then we're going to run the network meta-analysis model. That's definitely going to be the last thing that we're going to do. Okay, so remember, the first thing to do is to define your research question. You do your systematic literature research for your effect of intervention, meta-analysis research question, then you extract the relevant data, in several treatment arms that you're going to actually query in. Then we'll build a treatment network, which is what I'm going to show you in practicals by mapping out some of the direct comparisons to visualize the network structure. Then we run the network meta-analysis model. Now, the most important thing there is that as someone that really likes Review Manager, I've used Review Manager severally for several meta-analysis, but in terms of a network meta-analysis, there is a lot of limitations there, but there are actually a lot of packages, softwares that are quite very handy for you to start your network meta-analysis. And one of them is what we call the R software. Now, when you install your R, you also need to install the R Studio, which is going to give you a much more better interface for you to run your network meta-analysis. And some of the packages that are going to be very imperative for you to do that, we've got the NetMeta, we've got the GMTC packages, and lots of them. Okay, so these are actually powerful open source statistical programming language, with dedicated packages for network meta-analysis. Also, we've got Starter. Starter is also very important, a very good tool that is usually used for medical research, also social sciences, and all of that. So it's actually very important for network meta-analysis. Other ones that we've got is RevMan, but there are a lot of limitations because the RevMan interface supports a pairwise meta-analysis. And whenever I actually say a pairwise meta-analysis, we're talking about two meta-analysis that we're trying to compare one particular intervention with another, right? Compared to a network meta-analysis where you've got several interventions that you are comparing either directly or indirectly. Now, also another tool there is we've got Bayesian frameworks, like the Winbox, quite very important. And yeah, so basically, these tools, lots of them, they really make it very easy. You can actually check tools like Julius SPSS. But for much more compatibility, I would always really recommend R software for that, or Starter. Now, so what are actually some of the key take-home messages that I want to leave you with right now is that I just want you to understand that network meta-analysis is all about, it's more like it's simultaneous comparisons of multiple treatments, just like I explained. We are trying to compare more than two interventions at the same time, directly or indirectly, to provide a kind of a holistic view of treatment efficacy. And it's something that optimizes evidence. Just think about it that when we study a certain condition and we're just limited to comparing two drugs at the same time, it just limits the amount of evidence we can pull out from there. But compared to when we have a network meta-analysis, network array of drugs, and we are already comparing several of them to each other, it gives us that particular platform to understand which of them is best, or which of them has the best performance on the treatment pathway compared to single double pairwise meta-analysis. Now, also it guides decision making. Essentially, from that, it's going to lead to decision making. Clinicians, we know which study is more efficacious, and yeah, that guides decision making by making everything much more easier, and for clinicians to actually gain robust evidence. Another one now is validity. Assumption dependent. It gives us validity, which is one that hinges on critical assumptions like transitivity, consistency, which require careful evaluation. Now, the next thing, like I always do advise, is practice. And essentially, when you actually engage in practice, it gives you much more real-time knowledge, practical applications, and real-world examples of what to do, and a clear pathway of how to actually get started with it. So I think I actually want to use this opportunity to draw close to this particular crash course and introduction to network meta-analysis. And I'm going to actually be providing much more videos on how to get started on network meta-analysis practically, where I'm going to run you through R. Then from there, we'll actually get straight to action. So I actually want to say a big thank you for your time, and have a great day. Bye-bye.